Um, this is demo for how to use Gephi to visualize social network data. As we practiced in the class, I will go through very quickly first the dolphin data. So you downloaded the dolphin data from the link, and here you open the Gephi and click File, and we're going to import the spreadsheet. And here dolphin GML file, you just click on it and open. It's undirected and new workspace, and we're gonna say okay. Voila, now we have a social network of dolphins. I uploaded the paper with this clip so you can read about how they actually collected the data. Basically, according to the paper, every time a school of dolphin was encountered in the period between 1995 to 2001, each adult dolphin was photographed and identified. And so the tie is how often two individual dolphins were seen together. So this is data they've been collected for 6 years. So if you click at data laboratory, you can see these are the data we just imported to this file. Click on note, then you see this ID number for each dolphin from 0 to 61. So we have 62 dolphins, and these are the names for the dolphins. Kind of cute. Wave, right? So you can see Neat, Jana, and also you can click Etch. Then this is a tie, right? We can see it. So from ID number to another ID number, and this unique ID is randomly assigned to each type. So you can see the weight of H is still 1. So I think no matter how often they are seen together, if it's more than a random chance, then they code it as 1. So it's binary data. So let's go back to the overview. So now we want to have some readable structure of network. So this is a layout section, you can see. And for this particular clip, we're gonna go through very quickly the basic stuff, but you can pause at any time and go back to the moment that you need to take a look. So click on it. I usually use Force Atlas or this if and who, but let's go to the Force Atlas too. If you just run, and then we're gonna do this, right? And you can stop at any time. And here, if you click stronger gravity, then it's gonna collapse, right? And then stop to it. So usually we don't use this function. Unclick that again. Disturb hop, and then you can see they kind of parse out the network. So hops are distinguished from each other and prevent overlap, and then nicely arrange the network structure. So we can stop here. So this is the network. And here, this magnifier, you can click it, and then we're gonna center the network. And as I said, click on this button, then this gray box will pop up. Then you can play around the zoom in and zoom out. That's what we did in the class. So on the right-hand side, you have 2 tabs. One is filter and one is statistics. So let's look at it. So at the top box here, you can see we have 62 nodes and 159 edges, right? 62 vertices and 159 links. If you run the average degree statistics here, then this is average degree of the network. So on average, dolphins have 5.129 ties. It's kind of cute, right? And also we can calculate diameter. Click OK. Then the maximum eccentricity of 2 nodes in this graph, then we can see the number is 8. So we call it as diameter of the graph, it's 8. So we can also calculate the graph density here. As we said, existing ties, number of existing ties divided by the total number of possible ties with the given nodes. And this is not super dense, but so we can see the density is 0.084 here. And you can also think about the modularity. We didn't go through that too much, but this we're gonna give you how modular each subgraphs in the network, and also we can calculate a clustering coefficient here. Again, back to centrality, we're gonna actually have more centrality measures here. So the dynamic pattern here, once you have multiple networks that evolve over time, then you can actually analyze dynamics. But for now, we are not really dealing with the multiple networks. We just have one snapshot of the network. Actually, they collapsed the 6 years of data into one graph, so we're not going to think about this part. So as one of you asked at the class, these are the characteristics at the global level. So it's a macro level characteristic, but if you are curious about the individual node characteristic, then we're gonna go to the data laboratory and click on nodes. Then here, all the statistics that we did on the right hand side is automatically saved for each dolphins here. It's pretty cool. Also, you can sort them out. So let's see, we now know the diameter of the network is 8. We can sort it out by eccentricity. Then you can see the maximum number of eccentricity is 8. That's why the diameter of the graph is 8. Then we also can see the radius, the shortest, the minimum eccentricity of this network is 5. Cool. Also can sort it out by degree, and some of them have only one tie, and also the maximum degree is 12. And you can also see the close centrality between the centrality, eigenvector centrality. Cool. So let's go back to the overview. We're gonna reflect that statistical result to the graph. So on the left hand side, you see nodes and edges. Click on nodes, and this we're gonna change the color of each node, and this we're gonna change the size of the nodes. So let's play with the size first. And if you click unique, we're gonna assign every single node to size 10, right? That's as of now, we see. Click on linking, and then you will decide, well, let's say eigenvector centrality here. You can play around at the size. Let's say if I click 30, then we're gonna exaggerate the difference right here. If you click on apply, then this is what you're gonna see. Let's say 20, apply it to that, and then it's a little more watchable. And run it again to avoid any overlap here, because we clicked on the prevent overlap here. Then let's see what kind of color we wanna assign to that. Click on a node again, and let's change the color this time. And we're gonna see the ranking. Or we can do partition here. But let's try with the ranking. As of now, the size of node reflects the eigenvector centrality, right? So let's choose something different, degree centrality. And this is color palette. You can choose anything. So let's click on the red. So this is it. So as you can see, this node and this node are the same in the size, which means they have the same eigenvector centrality. However, their colors are different because number of ties they have are different, right? So you can have a little more information there. Now, what we want is to put, let's zoom in a little bit, the label on it. We want to know the names of dolphins. Then here at the bottom, you have a T. Click on it, yes, as their name. It's too large, too messy, it's hard to read, so we're gonna adjust the size of label with this button. So we're gonna change it to according to the node size. So the bigger node, which means more central dolphins, we're gonna have bigger label. And you can adjust the size of node with this button, like this. And on the left hand side, you can play with the thickness of tie. As of now, all ties are 1. It's not weighted, right? So it doesn't really matter. It doesn't mean much, but you can decide whatever you want. So this is the okay size, I guess. And here, let's go back to this layout again. And if you click down, there is label adjust. Then we're gonna play yes a little nicely on this map. Now you can see this is the single ego network. You can see we have overall network, right? So that's basically what we did in the class, and I want you to practice with this